Hello folks, Dr. Paul Piquel here. I'm an assistant professor of teaching at the University of British Columbia in the Faculty of Forestry. In this video, I'm going to demonstrate 4 new tools that we've developed to package together with our Minetest Classroom subgame for the Minetest game engine. And we've chosen these 4 tools for development because they're tools that are commonly used by forestry professionals, and our students also use these tools when they go out into field school. So the tools I'm going to show are a measuring tape, a clinometer, a real-world compass, and a rangefinder. So I'm actually going to demo the measuring tape and the clinometer together in sequence because they're what you would usually use together to measure the height of a tree, which I have here in front of me. So in order to use this tool, you simply wield it. As you can see, I can switch through my hotbar and wield whatever I want. So I'm wielding the measuring tape. I can walk up to anything. In this case, I'm going to measure the distance from this tree back to that spot I was just standing so that I can measure the height of the tree with the clinometer. So to use the tool, you simply left click. It'll highlight and show you your distance. And as you move away, it'll continue to count the distance, and I'm just going to come back here, click the ground, and that's going to highlight the distance, or the tape rather, between there, and it's going to show the distance up in the upper left-hand corner. So the distance here is 30 meters, and then it just automatically resets. So okay, so now I know I'm 30 meters from this tree. I'm going to switch to using my clinometer. To use the clinometer, just wield it, and then left-click to use it. And then you'll see this element appear on the right that is basically simulating the eyesight through the clinometer that you would see as if you were looking through it. And when you're using a clinometer, you're usually using both eyes. So you have your left eye open, that's sort of seeing the object that you want to see. And then through the right eye, you're seeing this element that's telling you your angle in degrees or percent. So degree is given on the left side of the scale, and percent is given on the right side of the scale. And if I move up and down, you'll see that those numbers adjust accordingly. So what I need to do at this point is to just measure the angle up to the top of the tree that I can see. So you can see it's 52 degrees or 128%. And if you have been studying how to measure the height of trees, you might know that you can get that measure by taking the tangent of this angle of 52 degrees, multiplying it by our distance, which is 30 meters to the tree, and adding to that our eyesight level. So let me exit this tool and just show you in a third perspective. And this is also true for anyone in real life who's using a clinometer. You have to account for the height above ground that you are standing at eye level when you're taking the measurements. So you have to add your height to this tangent of that angle multiplied by the distance to the tree. And that's how you get the accurate measurement of how tall that tree is. Okay, so that's the measuring tape and the clinometer. Pretty simple and easy to use. As I said, the clinometer, you just click it once to use it and click it again to put it away, and that's it. The other tool I want to show is a compass. And what's been really nice about developing this compass is that it supports real-world coordinates. And this might seem weird in a game like Minecraft or Minetest, but as part of our Minetest Classroom subgame, we've been building out support for respecting real-world coordinates when you create worlds. You can actually create real worlds based on geospatial data, and those can be attached to real-world mapped coordinate systems, as is the case for this world that we're actually standing in, which is a very small portion of Malcolm Knapp Research Forest. And so these are trees and forests that are actually created from LiDAR data, light detection ranging data, laser scanning data basically. And the positions and everything in this map are true to scale and are exactly where they would be in real life. So the height of that tree, for example, is exactly what that tree would be in real life. And so what's really cool about this compass and the way that we set out to develop it was to respect those real world coordinates. And so we wanted a compass that could actually be used with a real map and using a real world in Minetest. And so that's what we've developed. A lot of the compasses that are in like Minetest and Minecraft as default tools are not geographically aware. They simply point to some other location or some item or spawn point, and that's it. So they don't actually really give you any wayfinding experience, but that's kind of what we wanted in this new compass design. So when you're using the compass, simply left click to sort of hold it, and this is sort of giving you the indication of like this is what it looks like when you're holding it in your hand. You can click again to open it up, and you see your traditional bezel with the north, east, south, and west directions. What's really nice about our new design is that it gives you the impression that you would have when you're using a real compass. So for example, there's this sort of flipping out mirror that can be adjusted, and you use that so that when you're using the sighting hole, which is sort of through the middle top just above the north symbol there, so that when you're using the compass in the real world, you're actually holding it at eye level and you're adjusting the mirror down so you can still see the bezel. So that's a feature that we've kept in there, although it's not really something we've tried to simulate in the game world, so it's really just there to remind you that that's how you use the compass. Beyond that, though, it is more of a real compass. So you'll see that there's a needle that moves and adjusts just like a regular compass. This needle, though, is pointing towards the geographic north pole. And there's also an opposing needle, the sort of gray one that's pointing south. And then there's also the red shed. And if you've ever used a compass, you'll know that that's really important for wayfinding. So what's neat about this is that, of course, right now the needle is just pointing towards geographic north. So right now I'm facing geographic north. But I can also simulate magnetic declination with this compass. So if I right-click with the compass, it opens up a new menu where I can set the magnetic declination here. I can also set an azimuth, and I can get my current azimuth that I'm facing, which, as you can see, is nearly due north. So I'm going to set my magnetic declination here to 16 degrees, and this is 16 degrees. That is basically the difference between where geographic North Pole is and where the needle of my compass is pointing, which is pointing towards the magnetic North Pole. So these are separated by some distance, and depending on where you're at in the globe, you're going to have a local magnetic declination that you can set or would set for your compass for wherever you're using your compass. So here in Vancouver, it's 16 degrees to the east, and I'm going to set that and adjust the compass. And I come back here, and you can see now if I'm facing geographic north, my needle and my shed are just shifted basically 16 degrees to the east or to the right there. And nothing's really changed in the game world. I'm still facing north. It's just that my needle is not actually pointing directly north, which is more of how you would experience a real world compass. Is that most places in the world you're not going to be standing in a spot where magnetic north is directly in front of your line of sight to true geographic north. Most places in the world are going to be, some degrees to the east and some degrees to the west. So that's the idea behind setting the magnetic declination, is because it's something that you would normally do if you were using a real world compass. What's also cool about this, as I mentioned, that you can, if you right click, you can also set any azimuth. So if I set an azimuth to east, which is 90 degrees, I can adjust my compass. That'll automatically change the bezel. And as you can see, it's rotated the bezel. So now I simply have to turn until I put red in the shed, and then I'm facing roughly east. And we can also validate that by getting the current azimuth. And you'll see that the current azimuth is off quite a bit from the actual set azimuth. And the reason for that is because the magnetic declination is not accounted for in this current azimuth. So you will generally be within plus or minus, 1 or 2 degrees. And that's about as precise as you can get with this sort of pixelated compass bezel. So you see I can move quite a bit without it actually changing, and that's, just generally that's about as best as we can do. But nonetheless, gives you a good sense of like how you can actually use a real world compass. So that's the compass. You can click it again to put it away. You can use, of course, you can use that compass to set a whole bunch of waypoints, and again, use it with real world mapping scenarios, and do real world wayfinding in that way, which I think is really cool. The fourth and final tool is the Rangefinder. And the Rangefinder is a tool that we normally use in forestry just to measure the height of trees. And also you can use it to really quickly get distances to things and help scope out plots and that kind of thing. This Rangefinder has 6 different modes associated with it, which is I think pretty standard of a lot of rangefinders. Some might have fewer, like they don't have an internal compass and that kind of thing. But this one does support a height mode, which is the default mode, HT here. And basically, this is just like using the measuring tape and the clinometer together that I just showed you. You just shoot it somewhere along the tree, left click somewhere along the tree, left click again at the bottom or the top, and then left click again at the bottom or the top. And I missed that one. And there you have it. You have 40.3 meters is the height of this tree. So that's relatively easy. You can also try shooting, if you really want, you could shoot distant objects. So I could try shooting this tree over here in the distance and see if I can get the height of that. And sure enough, I can. That's about 42 meters. So in real life, this is complicated, of course, by the fact that you can't always see the base of the tree, you can't always see the top of the tree that you want to measure. Or, like if I were up in that forest, I'd be pretty crowded and it would be difficult to see anything. So those are some of the complications, and if I was trying to find any other tree, I just got to make sure that I have a good line of sight. So that's one of the cool elements of doing this in the game, is that you can kind of simulate those real world elements like that. So that's the height mode. There's also what's called missing line, and I'm actually going to fly for this one, show you how this works. So missing line simply measures the distance between two casts or 2 points that you shoot. So I'm going to shoot the distance between these 2 trees here. So I just left click and left click, and it gives me the distance between those 2 trees, which is 114 meters. So that can be kind of fun. You can also, as I said, there's a bunch of other modes on here. So let's look at those. We have slope distance, horizontal distance, and vertical distance. These are all of the sort of sides or faces of a triangle, depending on basically your position relative to another object. So if you're on a different plane, like if you're on a different horizontal plane, you're above or below some other object, you might want to account for that difference or that distance above or below in your calculations. So that's what these other features do. So slope distance gives you basically a line of sight distance. It just tells you how far you are along your line of sight to anything. So for example, this tree that's up here upslope of me, I could just click and I can see that I'm 119 meters from that tree along this angled slope. But say I want to know how high above or below that tree I am, I can also get that as well. And so if I switch over to VD mode, which is vertical distance, and do the same click, you'll see that it returns 29.4 meters. So that means that this tree or this location that I'm pointing to is almost 30 meters above me. So that's the vertical distance. And then finally, there's horizontal distance, which is the distance to something as if you were on the same horizontal plane. So again, this is useful if you're shooting upslope or downslope. So I'm just going to shoot the same tree, and you can see that the horizontal distance to this tree is 115.6 meters. And of course, that's a bit different than the slope the slope distance. So if I shoot the slope distance is about 4 meters further than the horizontal distance. So that's, again, accounting for that angular slope that I'm on. And then there's also inclination. So I can, it's basically the same as using a clinometer. If I'm standing in that same spot I was just in and then shoot the top of that tree, I can get the inclination in degrees, percent for that tree. So it's 128% is the inclination. You can also use the azimuth. Some rangefinders have internal compasses built in, which are really useful. So this would be akin to just using the compass, but it gives you an azimuth as if you were measuring from a compass. All right. Well, I hope you enjoyed that. Those are 4 brand new forestry tools for teaching and learning forestry. And that's all for now. Thanks for watching.